All right, section 1.8, radical equations. Much easier than the quadratic equations section, so yay for that. Okay, so there are three types that we're going to look at here. So type 1 is there we have a radical equal to another radical. Type 2 is just one side with a radical. And the third type is when we have rational exponents, which we already know that those can be written as radicals. Okay, so here is your instructions here. Eliminate the radicals by squaring each side, okay, or cubing, or whatever type of radical is going to, or whatever type of exponent will undo the root. Okay, so the opposite. And then solve the equation. And then here, a little special reminder, always check for extraneous solutions. Okay, so that's kind of the process here. Let's take a look at this first one. And we have radicals on both sides, so pretty easy. We're just going to square both sides, right? Because squaring a square root will just give you what's under the radical, okay? It'll just kind of undo the radical, and then you're going to be left with what's inside. So then this is going to equal 3x minus 20 is equal to 24 minus x. Then we're just solving for x, so super easy. Let's get the variables on one side. 4x minus 20 is equal to 24. Let's get the constants on the right side. 4x is equal to 44. Divide to isolate x, we get x is equal to 11 there. Okay, pretty simple. Let's look at number 4. It looks like all of these are matching. Number 2 is a square root and a square root. 3 is a cubed root and a cubed root. 4 is a fourth root and a fourth root. Okay, so instead of squaring, we're just going to raise it to the fourth power. Okay, because we have the fourth root, the fourth power undoes that. Same resulting thing, we're going to be left with the insides here. So 7m is equal to 7m minus 23 is equal to 3m plus 17. We'll get the variables on the same side. So we have 4m minus 23 is equal to 17. Get the constants on the right side here. 4m is equal to 40. And then isolate our variable here. M is equal to 10. All right. Easy peasy lemon squeezy. Let's go to the next section where we have a single radical. Okay. It's really not that much different than the first one. There's just a couple things you have to do in addition. So the first thing is you're going to have to isolate the radical. Okay. So we want the radical by itself before we square it. And then you're going to square it or cube it or whatever each side, because it's an equation, we have to keep it the same. And then solve. Oh, I didn't check for extraneous solutions in the first two, so make sure you do check for that, but I think those solutions are just fine. So we have isolated the radical here, so we just have the radical on one side is equal to 5, so we don't need to do anything to get it by itself. We're just going to square both sides. Then we get what's the radicand here. 6y minus 17 is equal to 5 squared is 25. Okay, we're going to get the constants on same side. Now we're just solving for y here. So that would be 3542 divided by 6. Y is equal to 7. Good. We could do number 8 here, because step number 1 would be to isolate the radical. And here we have 5 being added to the radical. So we're just going to subtract 5 from both sides to start with. So we get 2 is equal to the fourth root of w minus 11. And just because it's my preference, I like to have it on what we're solving on the left side. So I'm just going to swap those two just straight across the equal sign there. And then to undo this fourth root, we're going to raise it to the fourth power, and then we have 2 to the 4th. So on the left side, we have what's left under the radical. On the right side, 2 to the 4th is 40. And then we're going to, it's 16. I don't know where that came from. 16. Then we're going to add 11 to both sides. We get w is equal to 3637. 27. My goodness, I'm like trying to go way too fast. Okay, W is equal to 27. And that is that. Okay? So some more of those. Just remember to isolate the variable first. Make sure you are raising your radical to the same power that matches the root. Okay, so rational exponents here. So solving the equation with rational exponents is similar to solving an equation with a radical, but you're going to isolate the power first and then raise each side to the reciprocal of the power. So everyone should know what reciprocal means. It's basically a fraction that you flip, right? So we have a fraction here, 1/2. The reciprocal there is 2, right? 2 over 1, or just 2. So first we're going to isolate this power here. So we're going to subtract 7 from both sides. Then we have 6p minus 23, still being raised to the 1/2, is equal to 5. And then we're going to take each side and raise it to the power of 2. So we're going to square it. And as you can see here, what we know from our exponent rules, when you take the power of a power, you're going to be multiplying the exponents together. So now we're going to take 2 and multiply it by 1/2, which is equal to 1. So we're going to be left with 6p minus 23 to the first power, and in that case we can just write it as 6p minus 23. Then we have 5 squared is equal to 25 on the right side. Isolating the variable here, we're going to add 23 to both sides. We get 6p is equal to 48. And then divide both sides by 6. P is equal to 8. There's our final answer. And then let's do one more problem. Let's tackle number 16 here. It looks like this is a juicy one. Okay. So first step is to isolate the power. So we're going to subtract 7 from both sides. Then we have x squared plus 6x raised to the 3/4 is equal to 8. Wow. I need to go home, I think. All right. So then we're going to raise this to a power, and it's going to be the reciprocal of 3/4, which is 4 over 3. And then we're also going to raise 8 to the power of 4 over 3. So again, multiplying these together, it's going to equal 1. So we can just write the insides just as they are, x squared plus 6x. And then we have 8 raised to the 4/3. And if you recall from our rational exponents section, the denominator will become the root, and the numerator will become the exponent of the radicand. Okay, so then we can write this as the cubed root of 8 to the 4th. Okay, and then just kind of a shorthand way of doing this, the cubed root of 8 to the 4th we can write as 8 cubed times 8, right, which is equal to the cubed root of 8 times the cubed, 8 cubed times the cubed root of, oh my goodness. Yeah, the cubed root of 8 cubed times the cubed root of 8, which here we're going to get, this reduces down to just 8, and this reduces to 2, so we have 8 times 2, that's equal to 16. So this is actually going to be equal to 16 here. And then we're going to, then we have to solve this equation, but we're left with a quadratic here. We just practiced solving quadratics. We're going to try to factor this, so let's get all the terms on one side, set it equal to 0, so it's going to be negative 16 there. And then I think we can factor this 2 and 8, it looks like. X2, x and 8, positive 8, negative 2. Perfect. And then we have x minus 2 is equal to 0, so therefore x is equal to 2. Then x plus 8 is equal to 0, x is equal to negative 8. So our answers are x is equal to, and set notation, negative 8, comma 2. Whew. Okay. All right. There we are. All right, as usual, finish the rest of these problems and let me know